Okay, welcome to the unit talking about tangent lines. This is chapter 5, section 5 and chapter 10 of the second half of geometry. Tangent line intersects a circle in one exact point. If I trace this circle that's up here on the top of your page, didn't do a good job there. But a line could go through the circle in 2 points. A line could miss the circle. But if it has no points or it has 2 points, at some point it has to be tangent to that circle. So here is or example of what a tangent line should be. And when we do have a tangent line, the tangent line and the radius that hits right at that point of tangency is going to give us a right angle. And as you guys remember, anytime we have a right angle, well, we'll probably draw a right triangle, and that will give us some problems to work on. So let's go do those problems. So this first one here, we're going to talk about circle A. Well, remember, if we have a circle, we label it by its center point. So this is circle A. And at point C, we have a point of tangency here at point C, which leads us to point B. So there's a radius that comes from point A and gives us a 90-degree angle with point C. So we're going to finish it, and I'm going to draw a nice green line here from A to B and show that that's our hypotenuse of our right triangle. And what our point is we're trying to find AC here. So we're actually going to try to find this length. So AB is 17 units long, and BC is 14 units long. Well, anytime we know two sides of a right triangle, we just want to apply Pythagorean's theorem. So we're going to put an x here for the side we don't know, and we're going to apply it as x squared plus 14 squared equals 17 squared. Now x squared, obviously x squared, 14 squared is 196. And because I'm recording myself, I don't remember what 17 squared is, and there we go. 17 squared is 289. So x squared equals 289 minus 186, which will give us 93. So x equals, we got to take the square root of both of those. That's why we get just x. And the square root of 93 would be approximately a little over 9.64. So that's how we're going to find x. So if you want to try this next one by yourself as you see it, hit pause. I'm going to work on it right now, but hit pause and try it yourself. Or if not, you can follow along and listen to this one. So here's my circle, and we're going circle F and point E, and I'm going to draw it very similar. Maybe I'll draw it nice and flat. So here's my point E, and let's see if I can draw a nice flat line out this way. And here's my radius. And here's my hypotenuse, or the distance from point D to point F. So, again, we want to find the radius. What is this length? DF is 13. DE is 12. A lot of you guys already recognize this triangle, but again, let's call that looks like a 2. Our question mark, we'll call it side x again. So x squared plus 12 squared equals 13 squared. X squared equals 169 minus 144. And we find out x squared equals 25. So x equals 5. Another problem, or another ways to look at this tangent line is if a radius makes a 90-degree angle at a point with a line that is connected at this point, so here's my line and this makes a right angle, well then that line has to be tangent to the circle. So kind of just a converse of what our last little statement was. Converse is just switching the if-then statement around. And then this one is where we're going to kind of focus on the next part, and I always think this is kind of neat, is if you have a circle and you pick a point outside the circle, so since I'm running out of room, I'm going to put it over there, And if I find two lines that are tangent to that circle, so here's a point of tangency and here's a point, well, the distance from, and I'll put them in blue, so this distance here, that length, is congruent or equal, have the exact same measurement of each other. So from this point outside of the circle to the point of tangencies, we have congruent lengths. Okay, so how are we going to apply that? Well, in our next example here, we have two sets of problems. We have 2 points outside of a circle, so we're going to handle the ones on the left side here first, and its tangent from there to there. Well, remember, we just said this line has to be equal to this line. Well, if one side's 2x minus 3, we want to set it equal to 19, the other side. And we can just solve it from here. Remember, we have to add 3, so we want 22, and then x equals 11. And on the other side, we'll do that one in green. Again, from this point out here, this length has to be the same as that length. Set the two sides equal to each other. And we get, subtract the 2y, and we get y plus 5 is equal to 6. Subtract the 5, and we get y equals 1. So in this case, we know that this length here is 8, and we will put 1 in here, we also get 8. So shows that those two lines are congruent to each other there also. And I think that's it for today. So there's a tangent lines and some problems that involve tangent lines.